Next one is logical indexing. I told you we are going to go for not based on row number or column number. We are going to go for logical indexing. So we'll see what is logical indexing now. So you have a video. Please listen to the video. I hope the example was clear. So we are comparing the values above a particular threshold and we are making it as 0 or 1. That is what is being done. That is called as logical indexing. Elements satisfying the condition will be marked as 1. Elements not satisfying the condition will be marked as 0. And when you multiply the logical vector with the given data, you can extract the elements accordingly. That is what is the meaning of logical indexing. Logical means you are comparing with some logic and making the answer to be 0 or 1. Very simple. Okay, see here the example. I am having an x. X is a random number array. It has 7 elements. Create a variable named k, which contains values of true when x is greater than 0.4. K is equal to x greater than 0.4. So, like if I give this, will you get the answer of an array? I didn't display x, right? So I will display k and we'll see whether the answer is correct or wrong. Yes. So to see which all elements of x are greater than 0.4, you use this condition and one indicates yes. See the first element 0.5377 greater than 0.4 true. 1.83 true. -2 false. 0.86 true. 0.4 is a threshold, right? So 0.318 false. -1.3 false. -0.4 false. So this is a simple way of checking a complete array and getting the elements only above 0.4. It is just like I would say an example in image processing, you would have said about something called as thresholding, right? So whenever the image pixel values are more than a particular value, you assign it to be 0. Otherwise, you assign it to be 1. So you make the image a binary image from a grayscale image. Same thing is done. It is told in MATLAB in a different way. That's all. If you could correlate thresholding in image processing, this logical indexing is going to be exactly the same thing. So please, when you correlate things and learn, I feel engineering is going to be fun. Otherwise, it's going to be as boring as it can be like an arts and science subject. So now see, use k to extract those values of x that are greater than 0.4 and save in the variable xb. So if I want to extract that particular value of what all elements are more than 0.4, I already have the logical vector. So I'll be using the command find. Or I can directly give xb equal to x of k. Whenever the k value is 1, those elements will be picked by the x. So I'll submit. So when you display xb, see here, disp of xb. When you display xb, you will see that only those elements which are more than 0.4 will be displayed. Only 3 elements are more than 0.4, that alone will be displayed. So k is going to be the logical indexing vector, and when you give this as argument to the matrix x, it will display on those values of x which are 1, where k is going to be 1.